Okay. Good morning, everyone. This meeting is being recorded. I just started the recording. So the weather's starting to get a little bit colder. And I know that here at Shenandoah, we are checking the batteries and the block heaters. We're going through them, cleaning the temperature sensors on the max force engines, anything that is going to help the engine start a little bit better in the cold. Is anybody else having any ideas of any kind of maintenance tips that you guys are doing to help the buses start easier in the winter? I know we're all treating our fuels. That's coming up here in a little bit. So our last meeting was held on September 13th. Jeremy Johnson with New York Bus Sales presented on the Bluebird electric bus and any changes and modifications that have been made since the previous year. And a few of the items that he spoke about was that they're using 2 strings of 7 batteries together. They offer both air or hydraulic brakes on their bus. One of the other things that I thought was kind of interesting was that the high voltage system requires a signal from the low voltage system to be activated. So the bus still won't move, even though the high voltage system is fully charged and all that, and it's not going to work if it doesn't get a signal from the low voltage system. As far as we can tell, along with the rest of the manufacturers, motor bolts have to be torqued on a regular basis. He said you want to wait approximately 10 minutes after the bus is shut down before you start working on the system. They have a 10-year battery life expectancy. They said that their bus will not move so long as the charger is plugged in. That's something that I think we all had questions on, is if somebody could drive away with the bus and yank a charger out of the wall. And I guess that cannot happen with their bus. He went over the gauges and what they all do. There's a limited performance mode, and it's like a limp mode until the bus system cools down. So if the system gets too hot, it will go into a limp mode. And we'll find out if the Thomas bus does the same kind of thing here today. They have regenerative braking that, like we heard about from the both the other manufacturers, at 90% battery level. That's when that will kick in. And coolant flushes, it's going to be key to these electric buses. Every 5 years, their system holds 18 gallons of coolant, and it's not a simple coolant switch. They said that the job takes about 6 hours to do if you took it somewhere to their facility or wherever you're going to have it done. So those were some of the highlights of that particular meeting, and that meeting was recorded and is also on our YouTube channel. So feel free to watch that one anytime that you like. Today's presenter will be Roger Harrod with Matthews Bus Sales. He's going to be going over the Thomas electric bus and any changes since last year. So go ahead, Roger. The floor is yours.
All right, let's see if I can get this presentation started. Entire screen 2, share. Did we come up there, Dan?
Yes. Yep, I can see it.
Great. All right, let's take a look at what we're changing for our upcoming year. First, how to identify a Thomas bus. The other presenters did a good job of this. I thought it probably would be good to review this again. This is the standard, if you can see my cursor here, this is the standard side and rear panel badge that we use on the Thomas bus. We've used this for years. Has a red inlay The blue signifies that we have the electric version. Likely the hood badge is the same thing. We've gone to a blue badge on that. There's a sticker, which we're seeing on the side of the bus. Again, blue in color. And lastly, we've got a hood ornament on the side of the hoods on both sides. Our major supplier of our electricals, batteries, all those components is Proterra. And it says Proterra powered on both sides. In most of these cases, you see the color blue. We'd like to relate blue to batteries. In fact, we even have an option for a blue bumper, though I believe Jeff Corey's already told me that they don't care for that in New York State. But that's how you would identify a Thomas Electric chassis. The current chassis we're building, our Gen 1, we've had out for a number of years now. It's a pretty simple package in the fact that all the air system is in one place. It's at the rear of the bus, mainly because there's nothing else back there. The battery and powertrain are in between the two axles, and all the control system, except for one piece, the inverter, is located here up in front of the bus under the hood. Now, this chassis has done a pretty good job for us. So we have sold a total of 9 units, delivered 9 units across the state. And right now I currently have orders to be delivered of another 20 units. So we're actually doing very well with the package. This has done a very good job for us. Ours is somewhat unique over the other manufacturers in the fact that we're still operating with a transmission. And there's a good reason for that transmission. We have learned that we don't need a huge battery to get this vehicle down the road. In fact, it only takes about 170 horse at 65 miles an hour for a school bus to maintain that speed. We have a smaller battery, or a smaller, motor assembly. It tends to work a little bit more efficiently at that horsepower range, but it lacks torque to start. So to start the vehicle, we've incorporated a 2-speed automated box. And all this does is get the vehicle going, get it up to around 20, 30 miles an hour, shifts into drive, and the motor is fine. This has really worked well for us, except for a couple limitations. One of the big limitations is it's limited us to a 259-inch wheelbase. And we would like to build a chassis in other wheelbases. The second problem is that we don't have room for expansion on our battery packs. We have run out of room here. So we are making a change for 2024 for our Gen 2. And the big change is, number one, to get rid of the 400-volt system. We would like to go to a higher voltage. The second system is we're going to eliminate all of these components right here. They're gone. And they're going to be replaced by the Meritor e-powertrain package. This is a rear axle differential with a motor, electric motor, 2 different sizes depending on the weight of the vehicle, and a 2-speed transmission built into one assembly. Now, this particular assembly shows it with disc brakes. As I and the other presenters have already made the comment, we would prefer you using disc brakes because it uses less air, meaning the compressor doesn't have to work as hard, and it actually extends the range of the vehicle. And I, secondly, do not know if drum brakes will be available on this new axle. But again, this is preliminary information as well. Now, the only connection between this and the rest of the vehicle is 3 cables and 2 coolant lines. What that does, and also allows us to go to an 800-volt system here, which we would much rather prefer. And what we end up with is the same setup: air systems in the back, control systems in the front, battery and powertrain in the middle. But right in the middle of this package, I got a big empty hole. And that's going to allow us to do some additional things. One of which, we're going to increase the size of our batteries from 226 kilowatt hours to 244. We still only have 2 batteries. We're just making the batteries longer. The next step is the 259-inch wheelbase. That's the only thing we could produce. We're going to add 3 additional shorter and 1 longer wheelbase to our product line. Starting gradability is still 28%, and at 30 miles an hour, we can still maintain a 6% grade, which is what we want to do. DC fast charging rate. That increase in voltage allowed us to increase the ability to take a charge. So DC fast chargers, we can now take as high as 120 kilowatt hour, 120 watt kilowatt charge rate. 12-volt batteries, we've also had the ability now to increase the charge rate if necessary up to as high as 400 amps. Now, we're also going to get a new instrument cluster. We're sort of needed that one. And we still are vehicle to grid compatible for those districts that wish to do that. Charging, I have to go over charging a little bit because noticing in the other presentations, their charge area looks different than ours, and there's some difference in the lights. When you open the door to our charging port, there is a weatherproof cover which you have to lift up. There are two lights, a green and a red light, and a black button. Now, when you plug the charger in, this will latch over this area of the charger, but there will be an audible click you can hear, which is when a pin right there engages over the top of this and locks this connector into the charge ports. This cannot be removed unless you hit the charge release button. Now, once you plug that in, the green light will start flashing rapidly. What's occurring at this point is there's what's called a handshake occurring with the charger. DC fast chargers are smart chargers. They can charge anything from 200 to probably 1,000 volts. Obviously, when we've got an 800 volt system, I want to tell it that's the voltage I want. So we have this handshake occurring between a component called the charge management system in the bus and the charger establishing the charge rate. That's that fast flashing. When that is accomplished, we have a slow flash on this light, which will continue to flash slowly until the bus is totally charged, at which point you see a steady green light. At that point, you could push the end of charge button. In fact, you can push that at any point during charging. That stops whatever is charging at that point, releases the lock, and we are then able to push the button and remove the connector from the assembly. Now, the red light is the light we really don't wish to see come on, and that is a charging fault. You could plug in the charger, you will get the fast flash, and instead of the slow flash, you see a red light. That means the charge attempt has failed. The best thing we can do at this point is release the charge button, disassemble it. They ask us to wait several minutes and try it again. It could be a handshake was not accomplished, or it could be as simple as you didn't have the charger fully engaged in the connector. And you should the second try should work. If it not, you're going to have to call your charge people, find out what's wrong with the assembly. Now, two locations. We have a forward location near the entrance door of the bus. We have a rear charge location available on the curbside about 4 feet ahead of the rear bumper. Also, similar to the other operations, when the connector is plugged in, not just charging, if the connector is plugged in, you cannot release the parking brake and you cannot shift out of neutral. That is not allowed. All right, the control system basically is the same as it was with Gen 2. We're using the high voltage junction box. This is the major component and controller of the system. The charger goes to here and then goes to the battery. The power from the battery goes to here and is distributed around the chassis. The nice part about this system is you normally, in all of your maintenance repairs, would never have to be involved with the high voltage connections. All the high voltage connections to this box are either on the back of it or on the bottom of it, out of sight. In fact, looking under the hood of our chassis, it's very difficult to see anything that is orange in here, signifying high voltage, with one exception. Right here is a disconnect switch for the high voltage system. You're turning that switch, you are turning off the high voltage system. Now, here we see the whole charge package arrangement. The batteries are being charged, charge management's involved. When the driver gets in and puts the key over to the start position, power then comes back to the high voltage junction box. It sends power to the inverter back near the motor. When the driver depresses the throttle, high voltage would then go to the motor and drive the assembly. The high voltage junction box also sends high voltage DC to an air conditioning compressor right here on the firewall to 2 heaters mounted underneath the chassis, about where the Allison transmission would have been mounted, and to a 14-volt inverter, which is charging the 12-volt system. Now, this is all high voltage DC. Motors don't like DC, they like AC. So I have what's called a variable frequency drive, which converts high voltage DC to AC, and that provides the power for the air compressor motor at the rear of the bus and the power steering motor, which is right here. And actually, the power steering pump ends up in about the same location it was with the diesel package. All this high voltage is only in the chassis. The body is still 12 volts, so I've got 12-volt batteries, and I've got a low voltage battery disconnect switch here as well. Incidentally, this switch for the low voltage system and this switch for the high voltage system are the only switches on the bus. If you need to turn off low voltage, you can turn it off here. High voltage is turned off on the front of the high voltage junction box. We're still using the same air compressor assembly at the rear. There's your high voltage AC line to our high voltage motor and a rotary compressor. And the rest of these components back here are conventional C2 components. There's nothing odd or special about them. Cooling system. We still have 3 cooling systems. The power loop system is using the conventional C2 radiator and top tank. It's connected with an electric water pump, 12 volt, to all of these components. Since they create heat as they operate, this maintains them within their safe operating temperature. The second system is still a battery thermal management system. Lithium-ion batteries are a lot like humans. They work very well at 70 degrees. They charge well, they give power back well, they store energy well. But when they get cold or when they get hot, just like humans, they don't work as well. So the function of this system is to maintain that 70 degrees on that battery pack. And it's done when it's cold out with a heater and another electric water pump, pump number 2. When it's cold out, we have an air conditioning system and a chiller on the right frame rail. They both this system, battery system, and the power loop system, the first one we saw, share the same top tank. And that top tank gives both these systems the ability to vent any air and to expand and contract. The second tank, again, just like the Gen 1, is for the cabin heat system. Now, cabin heat is one of those areas that all electric vehicle manufacturers dread, because quite honestly, there is no surplus heat in an electric vehicle. If you want heat to heat the inside of the bus, you have to make it. And that heater, as it gets warm, takes a lot of energy out of our battery pack. In the driver presentation, I go through the operation of this very extensively, because we control the heat in the bus differently with an electric vehicle than we do with a diesel or a gas unit. We've got a heater which actually consumes 20 kilowatts when it's at full load. 20 kilowatts is the second largest load in the entire bus. By operating this system efficiently and correctly, we can have the ability to reduce the output, the input, on this assembly. And by doing so, I reduce that load on my batteries. The important part is to keep in mind is heating the bus does affect the range of the vehicle. Absolutely does. A 20 kilowatt heater, whether it's on my bus or on a Bluebird or on an IC, at full 20 kilowatts is consuming the equivalent energy to drive the vehicle around 13 miles every hour it's in operation. So this is something we need to control very carefully with the drivers. We spend a lot of time here with them. Now, also, heating can be preconditioned during battery charging. We can actually heat the inside of the bus while we're charging it. But if this is an option you wish to do, you have to let the manufacturer know before you order the stuff, because we have to make sure the bus is set up for this preconditioned heating and the chargers are also suitable. We have one supplier locally that has units, or one customer who has units with chargers that will not do this. So let us know before you order. Now, regenerative braking, everybody's got regenerative braking. It allows us to recover some energy and actually effectively reduce the speed of the vehicle. There is no deactivation switch, but there is the ability for ABS to turn that off. We had a slippery road condition or any situations like that, ABS still works. It will cut off the regenerative braking. When you take your foot off the accelerator, it starts automatically. And when you apply the brake pedal, we give you more. So you see some range of horsepower is available in this braking effect. By the way, we get more torque when we're in our low range of our transmission than we do in the drive range. Now, this makes a lot of sense if you think about an engine with an engine brake. If you apply an engine brake and your transmission is in range 6, for example, you get very little engine braking. But if you were to downshift to range 3 or range 4, you get considerably more. In fact, when our transmission is in the low range, we get 50% more torque in low than we would in drive. Again, like the other manufacturers, when we get above a certain state of charge, ours is 95%. We will reduce the amount or limit the regenerative braking because we actually could overcharge our batteries. When you're below 95%, you will get full braking effect. Above, you'll get slight reduction. And unlike an engine brake or a transmission retarder, we can actually stop the vehicle with regenerative braking. It's a neat option. Now, battery capacity, this is Gen 2. We've increased the size of our batteries up to 122 kilowatt hours, and we do only have 2 batteries. You see one of them here. The second one is mounted above this. Total capacity on our batteries is 244 kilowatt hours. Now, you can't use all of that. If you completely discharge and recharge and discharge and recharge any battery, you directly affect its longevity. So to increase the longevity and reduce the degradation of the batteries, we can use 90% of those batteries, or 220 kilowatts. That's actually a very good number. It's much higher than most of the battery assemblies out there. That 226 gives us a good range with the vehicle. We're also protecting the batteries on the front with a steel skid plate, and the case is made of 10 millimeters of ballistic grade aluminum, which is really very, very effective to protect the batteries. Now, we're actually looking here at the rear of the battery packs. Our battery connections are on the very rear because that's the safest place to put them. And that's the only reason they're there. Now, the range on that battery, this is Gen 2. We've got 244 kilowatt hours that we have in the batteries. We can use 220 of it. Now, our batteries, our vehicle efficiency is listed as 1.5 kilowatt hours per mile, or that's my battery energy usage per mile. Now, if you know how much I've got and you know how much I'm going to use, it's pretty easy to divide out and find that the maximum possible range on this is 147 miles. And I will guarantee you this second that you will never get 147 miles on these batteries. Why not? Because the actual usable range of any of these systems depends on the route, the driver, the temperature, and the frequency of stops. With our Gen 1, a good range was 115 miles. We've increased the batteries for Gen 2. A good range for Gen 2 is 125 miles. That's a number which is attainable when it's warmer out, because when it gets cold out, the heaters are going to take away some mileage. And that's a fact of life for any of these manufacturers. Now, we also equipped every system with the IntelliPark brake system from Bendix. This is now an option also on our C2 product. This is an electric park brake switch. You pull it, basically put one finger under this lip and just pull it out. You've engaged it. To put it off, you push in with one finger. This means the old PP1 valve and the carpal tunnel and all the other problems with some of the smaller drivers is gone. To operate this, the ignition must be on. It's a 12-volt switch. To release it, you also have to depress the service brakes. When the LED will be illuminated when it's on, it will be off when it's released. Now, the system can also be manually applied for emergency braking. It's a pretty slick package. If the bus sits stationary, however, with no throttle movement and no service brakes. Now, this is not a common situation. Even if you're stopped at an intersection, typically the driver's got their foot on the service brakes. But if this situation exists, bus is sitting stationary for 30 seconds, no throttle movement and no service brakes, the system implies that the driver isn't behind the wheel, and it will set the brakes automatically, and the transmission will automatically be shifted into neutral.
IntelliPark is designed to help drivers mitigate rollaway and runaway crashes. How? By setting the parking brake if the driver forgets to, or if it is accidentally disengaged.
Now, when this system auto sets, the lights flash. They aren't on continuous. It's telling the driver they didn't do something right, and the system did it for them. To reset this, they can't just put their foot on the brake and push the switch in. They have to manually set it. So they have to stick one finger behind the switch, pull it out, which will apply the brakes manually. They then can apply the service brake, push the switch, and it will turn it off. This system, again, will not release if the charger is plugged into the charge port. Will not. Okay, basic high voltage disabling. I want to take the bus out of service. This did not change from Gen 1. The simplest thing to do is to turn off the ignition switch and remove the key. Similar to every other system, the high voltage system on these buses are controlled by the 12-volt system. If there is no low voltage, there can be no high voltage. Now, to better assure that this is disarmed, the next thing you would normally do is go to the battery box, turn the low voltage disconnect switch from the on position to the off position. The third thing you can do is go to the high voltage junction box. And on the front of the box is the high voltage disconnect switch. You rotate this counterclockwise, one click, and you've disconnected the high voltage completely. Now, both of these switches are set up for lockout tagout. And in fact, if you look at one of the shows of one of our vehicles on the floor, if you could look in those two areas, you would see a padlock on both of them so that no one could inadvertently turn the system back on. Now, required training. This didn't change, but it's worth talking over again. To work on, to drive, to maintenance, to make repairs on a low voltage system, drivers and other personnel in the shop, cleaners, whatever they are, people working around the high voltage units should complete the HV1 training program. That's about an hour-and-a-half program. There's a driver training video, there's a charging video, there's some general information on safety around the shop and around electric vehicles, what you should do, what you should not do. If you're actually working on the bus, making low voltage repairs and maintenance, you have to complete the HV2 program, which is about an hour longer than the HV1, because we're also going to go through the maintenance components, some more safety component areas and other areas of importance. Now, completing this program today doesn't accomplish either of these. You've still got to go through these if you have the buses in your fleet. And we will normally train at no cost at your location, usually at the time of delivery. Now, to work on the high voltage side, maintenance and repair, you have to complete the HV3 training program, which is a 3-day factory program that is extremely intense. And right now, the factory has not made this available to you. So at this point, the Thomas dealer only is the only source for high voltage work. We talked about high voltage disabling a couple slides back. These are the MSDs, or manual safety disconnects. These are involved with another operation called decommissioning. Decommissioning is what we have to do to the bus to physically work on a high voltage system. Daimler, Thomas, Freightliner, all three are very concerned and very cautious when working with the manual safety disconnects. One of the reasons is because even if you pull these, there could be residual voltage in the system. There are what's called capacitive discharge assemblies that are designed to remove that, but we have to physically go in and measure this before we can make any high voltage repairs. For that reason, that reason only, we recommend that decommissioning, removal of MSDs is only to be performed by an HV3 certified technician. Now, the warning lights on the dash. We got a lot of warning lights. Everybody does. But the high voltage ones are pretty consistent across the industry. We have a previous dash. You'll see a picture in a second. We've got a new dash that I don't have a really good shot of, but the symbols don't change. And these are what I call non-fault symbols. There's nothing wrong with this light. It's one that you would be looking for. This is the one that says high voltage is active and the vehicle is ready to go. Our particular light shows a truck chassis on it. One of the others I saw in one of the other presentations had a little bus on it. I wish ours had the little bus, but that's what we got. Now, another non-fault symbol is this one. This looks like a charger plug. That's what it is. And it basically is telling the driver, this light came on the dash, but this light's still lit. That means he can't go anywhere until he does what? He has to go out and remove the charger from the charger port. Another non-fault symbol is this one, and this implies the shape of a turtle. And it means that you are in limp mode. And there may be different things this turns us on in different manufacturers. In the case of the Thomas product, if we drop as far as down as 8% of battery state of charge, 8%, this light comes on. And at this point, you are also derated by 2/3. You only have 34% of your energy left to use in the traction motor. It's also cutting off everything it can to minimize the electrical load on the high voltage batteries. Why? Because in limp mode at 8%, you might have enough energy to go another 10 miles. To think of it another way, this would be a diesel bus with 1 gallon of fuel left in the fuel tank. This is not a fault. This is a failure of someone putting in enough energy to meet the requirements of the particular run. Now, our dash, this is the Gen 1 dash. It has what's called a man read area, which will display information. Normally, this area shows the odometer reading, the voltage in the batteries. This shows the temperature of the traction motor and the temperature of the battery pack. It has the ability to give you messages. For example, it says the IntelliPark service system should be serviced soon. It may also say regeneration limited. It may say low voltage, which, by the way, is a low voltage fault. But this is not a fault again. This is giving you information about the bus. Now, we don't have these guys, which means I don't have this either. I don't have a mill lamp, but I do have some fault lamps. The first one represents a motor. There's a motor, there's the shaft, there's an exclamation point in it. There's two of them. One is yellow, one is red. They're just like an engine fault. If it's yellow, you can continue going, get the thing serviced quickly. If it's red, pull over to the side of the road. There's no difference in results. Second one is the battery pack. There are two of them. You see it represents a series of batteries. There's an exclamation point. There's a yellow one and a red one. Again, the same process. Yellow, we could continue to use it to get it safely home. Red, we're not going to make it. And again, this is no different than with a diesel unit. The next one's an interesting one. This is the one that looks like a triangle with a lightning bolt in it. And the definition of this is high voltage interlock loop compromised. All of the high voltage cables that go to the high voltage junction box have obviously high voltage wires in them, but they also have a small circuit of 12 volt with two connectors that are designed to come together last And if the connector was to become loose, they would come apart first. We also have a number of cases with high voltage in them. For example, the drive inverter, the high voltage junction box itself, the variable frequency drive, the battery box. Those covers are bolted in place, and underneath each of those covers is a micro switch. Again, a 12-volt circuit. So if the cover was to start to become loose, that circuit would open. If any of these circuits open, that light comes on. And that tells the driver only one thing: get this bus home. It is safe to drive at this point. Get the bus home, but do not park it where you normally park it. Park it in front of the garage. Because once you shut the vehicle off, it will not, under any condition, restart. It is dead. That allows the shop to pull it in the garage, and then we can determine the cause of the problem and repair that before it goes back into service. Now, the last light we see on electric vehicles, that it's kind of a strange one, looks like a wrench, and it's defined as service required. And this is usually a minor situation. The diagnostic software would tell you what it is in the case of this. In fact, the diagnostic software is available from Proterra, a read-only software at no cost. We've actually seen this light flicker on at times. In a few cases, if you plug in later, there's nothing there. And the factory is actually evaluating what this is doing as more and more units are out in the field. Not a problem, though. Okay, what additional maintenance is required with our electric vehicle than the normal PM we would do on a chassis in general? Well, number one is a daily maintenance, which actually is a driver thing. Because daily, we want to inspect this charge port and that charge connector every day. We want to make certain there's no broken pins, cracks, bent components, obstructions in here, anything that would cause a problem for the charging system. Monthly, our air compressor needs to have the oil level checked. Now, there is no engine to supply oil to this, as in the case of a diesel unit. So it has its own oil supply. We've got to check the sight glass, make sure there's oil. And if there's not, we're going to remove the fill plug and put oil in it. And there is the oil we're using right there. Now, every 6 months, since the whole air system is at the rear of the bus, it gets a little dirtier back here. We've got to change the filter on the air compressor, and there's 2 filters inside there. That is a 6-month interval. 12-month, we're going to make what's called a torque inspection. Now, what the heck's a torque inspection? The torque inspection could be, are your lug nuts tight? It could be, are the transmission mounting bolts tight? Is the suspension nut fasteners tight? The steering? We're going to through and check whether, and it's basically a visual with a wrench, do we have everything tight like it's supposed to be? While we're back looking at the transmission and motor, we've got oil in the transmission. There's a fill plug. We're going to pull the fill plug and make sure we've got oil inside there. If not, we're going to fill it as necessary. I'll show you that fluid a little later. Now, this is an interesting little spot here. This is what's called a torque mark. Thomas Bus uses this. Freightliner uses this. We use this in PDIs. Once we go through and verify the torque on a fastener, we will mark it with a little dye, a little paint. And I got this off the internet. You can buy this. A factory uses a green tab. And when they come in, they have checked the major fasteners. When we do a pre-delivery inspection, we go through with yellow mark. If you look on any Thomas bus, you'll see green and yellow marks on the threads, indicating what? We have checked the torque on that fastener before we've delivered it. This is not a bad system to use in any shop because it gives you a visual cross-check. Did I actually check the torque on that nut or bolt? Yes or no? Good system. Now, also at 12 months, we're going to maintain the cooling system. We have 3 cooling modules on this assembly. We got a powertrain cooling loop for the traction motor and all that stuff. That uses the radiator and the top tank. The battery thermal management system uses that same top tank, and it also has a heater. and it has an air conditioning system with coolant lines on it. We got a body heat system. It uses the other tank and uses the other heater core. We've got 3 electric water pumps. We got 12 gallons of coolant in this top tank for these 2 systems. I've got another 13 gallons in here for the dash body heating system. And we're going to use OAT 50/50 premix coolant, which is the same coolant we've been using in the diesel units at Thomas since 2016 as standard coolant. Please, please, please do not use tap water in any electric vehicle. In fact, for any vehicle. Tap water does what? This system right here is pumping coolant through your battery packs. The last thing I want to do is plate that hardness from that tap water off on the inside of my battery packs. That is going to be a very expensive, non-warrantable failure. You don't want to do that. Now, we use a vacuum fill with the proper procedures to fill these systems. There are too many nooks and crannies on an electric vehicle system to just fill the system. You must use a vacuum fill. You must use the proper procedures. Now, this is a red maintenance. You can't do this one. Our batteries contain a desiccant pack in both of them. This has to be changed annually. Now, think about it. The battery is the most expensive single component on any electric vehicle. And the last thing you want to do is anything that may negate that standard 8-year warranty on this package. Proterra considers this their 15-year battery. That's going to well outlive the chassis. But the warranty, again, you can get an extended, but you don't want to jeopardize your warranty by not changing these. This means you come into our shop once a year and we change these desiccant packs. We also, at the same time, are going to change the oil separator element and main seal on the current air compressor. There is a discussion on changing air compressors on this, but this is the current one we're seeing right now for the Gen 2 as well. 2 years. The power steering motor right there has 2 grease fittings, and you've got to hit both of them with some lithium grease. That's it. Now, this is also a very pretty handsome picture, because in it you can see there's the air compressor for the battery thermal management system. There's the high voltage junction box. There's the variable frequency drive, which provides the power for this and the air compressor motor. There's the 14-volt inverter, and there's the processor, the M560 computer, which controls all this stuff. Everything in our control system, except for the inverter for the motor itself, is under the hood. It's all in one place. And if you look here, there's no orange cables. All the orange cables are out of sight. Now, every 3 years, there's an air compressor rebuild. We'd have to do that one, but there is a fluid change for both the Gen 1 Eaton transmission and the Meritor e-Power system at the same time, different fluids. Every 5 years, we've got a coolant change requirement and a power steering fluid change. Are there any questions?
Yeah, I got one. That 3-year and that 5-year, that has to be done at your shop?
Nope. Only part that has the 3-year is the air compressor.
But that yearly one has to be done by you.
The air compressor has to be done by us. Again, you're looking at a 1-year maintenance on components every year anyway. So the 3rd year, we would also do that.
So what's the cost rundown on that right now? Because like we're trying to compare numbers to see what this is all costing us. But
Sean,
we're not hearing
Sean, are
anything.
you online yet? We just completed this for Bethlehem, and I saw Sean was on here early. Apparently, he had to go off.
No, I'm here.
Okay, can you give any idea on cost on that yearly?
Oh, there's 4 of those little green plugs that have to go in the battery. At the moment, they're about $52 a piece for those salt plugs. There's 2 of the desiccant filters that are about $300 a piece. And then you're looking at the compressor kit with the filters at about $600. And I think it's about 2 hours in maintenance for us to decommission, put everything in, and put it back together right now.
Bottom line?
Bottom line, we are looking at $1,800.
Okay, thank you.
So that's $1,800 every year that it's going to cost to maintain a battery.
Yep.
Okay. And that's both batteries.
Yep, that's everything.
Okay. All right.
Roger, I'm curious, what is the refrigerant system on this? Is it R134 or is it the YF?
Sean, again, you've got a little bit more experience than I do on that.
Ken, at the moment, it is 134. I believe the factory at some point next year, the year after, is going to go to that new 1234 YF.
Yeah, Ken, we'll see that in the 25 model year.
Okay, is there any maintenance schedule on that refrigerant system also? Charging, filters, whatever?
We've not been advised of any.
Okay. Thank you.
The disconnects, high voltage disconnect that you showed. So some of them have the blocks like that you would pull out.
The
Yeah.
MFCs, yeah.
Yes. So this is just as easy as turning the switch
Yep.
to turn that off in your application, correct?
Yep. To disconnect high voltage, there's only one switch that's up on the high voltage junction box. Open the hood, it's over the right wheel. Turn the switch counterclockwise, 1 click, and your high voltage system, as far as your needs are, that's all you have to do. Now, for decommissioning, for us to actually work on a high voltage system, we have to, in addition, pull the MSDs.
Mm-hmm.
And again, there is some cautionary areas there because that has to be done correctly. And again, that takes the training of an HV3 tech. And PPEs, by the way. There's quite a bit of personal production equipment we use with those systems.
Okay. Is there going to be the equipment that we're going to need to work on the low voltage, is the low voltage section?
There's really nothing special there.
Okay. Others, you mentioned about the bus entering limp mode.
Mhm.
If the battery gets to 8%, will it enter limp mode if there's a compromised electrical component, like if it starts to overheat? I know that's
There's again, there you would see your red lights on the dash.
Mhm.
We have not been advised of any other modes that will cause a hesitation in the system. When you start getting below around 15% state of charge, which is a good point to think of as the recharge point, 15%, the system will actually start turning things off. The driver will lose air conditioning, for example. Eventually, as it goes down further, you'll see the heaters will shut down in the bus. And again, trying to conserve energy because we're getting very low. And the number one thing that the system is trying to do is keep the bus moving. So as it gets lower and lower, below 15%, you will see the bus start to hesitate, much like your cell phone. When you get to about 5% on your cell phone, the screen goes dark. And it's telling you, you can still use me, but I'm going to run out of power shortly. And I'm going to continue to operate as long as I can with what I have. But again, it's very similar. These systems will start to tell you, I want to be charged. And that's the important part of it. But they will continue to try to move the vehicle. That's the last thing they turn off, is that. At 8%, you're really down. That's a dangerous area to be in for getting home. Now, you can always do what? You can run the battery dead and you can tow it home too. Be advised, 15% is a good place on any of these vehicles to say, I really should be charging this. Because at that point, the system's actually going to start telling you, you're going to lose cruise control, for example, at 18%. My cruise control doesn't work. Yep, take a look at your state of charge letter. It'll tell you why you just dropped below 18%. So there's all kinds of systems here. They're make it easier, make it more intelligible, and make it simple to work with.
All right.
Hey, that yearly, I'm big on the extended warranties. So I'm sure that yearly program there is part of it. Is that something you come to our shop and can do? If we provide you a bay, you can do that in our shop. And
there's nothing magic here that says you have to do it in one place. We do have to put stanchions around the bus to identify it's an area you should not be coming into. But yes, that's all we need to do. If you need to buy anything for your shop, I would buy 6 stanchions with the expanding chains between each one, so you could stanchion out an area and say, don't go within this. And if you had a fleet of Teslas, I tell you the same thing. Because when you're working on a high voltage system, the technicians that are trained for it are inside those stanchions and everyone else stays outside of it.
Okay. You mentioned Proterra software for the batteries.
Mm-hmm.
Now, and that's for the charging system in the bus as well?
It's for the whole bus. So they're all of their system.
All right, so it's totally different. We don't need to purchase at this point any kind of software to work on.
Nope.
And well, let's say ABS. Like
that's ABS. All the other systems on the chassis, which are standard 12-volt systems, use the same diagnostic software they're using today. There is no difference on those. The only difference on this one are the components under the hood, which are the Proterra components. Those are the ones we need the additional software for.
All right, so we're still going to need our subscriptions to anything else, the ACOM, all this stuff.
Yep.
Okay. Does anybody else have any questions for Roger? All right, if you think of any, please email them to me and we'll make sure that your questions get answered. Thank you, Roger, for your presentation.
Thank you.
Again, for everybody else, it is being recorded and we'll put it on our YouTube.
Thank you, Mr. Harrod.
We have George Gill's probably got another year left as the vice president here. So we need somebody to step up to the vice president position. We're also still looking for a treasurer. So please help out if you can. Just shoot me an email and we can go over what we need to do. The ASE program is still going decent. James Lorette has the manuals that we purchased and he's studying up for his ASE Master School Bus Technician certification. Our next meeting will be held on November 15th. Al Carroll from Shenandoah Central School District will be giving us an update on EV buses and infrastructure and his findings. He's doing an awful lot of research on this stuff, and he's going to be our next presenter. In December, our December meeting, our presenter will be Mickey from DEC. She's going to be going over the laws and regulations for fuel islands. So all of our fuel island inspections. So when they show up, she's going to go over what they're looking for our fuel stations, which, you know, as we get into the electric buses, that may change, but for diesel and gas, she's going to go over this stuff with us. That's going to be December. Does anybody else have anything to add to today's meeting? Okay, not seeing anything. I'm going to go ahead and close the meeting. I want to thank everyone for coming to the meeting, and we'll see you guys on the 15th.
Thanks, Dan.
Thank you. Thank you, everyone.
We'll see you later.
Thanks, Danny.
No problem. We'll see you later.